Optimizing payloads for the USB Rubber Ducky with attack mode and arming mode, this time on Hack 5. For Hack 5, I'm Darren Kitchen, and today we are diving back into the payload that in this series we have been finessing and optimizing and adding to, and this is the perfect example to get into one of those fun nuances that's kind of similar to the previous one about that initial delay 3000, and now we can replace it with DuckyScript 3.0 with an extension to do it more intelligently and faster. And it brings up the concept that, hey, you know, there's a command that we use quite frequently with the USB Rubber Ducky. It was first introduced with the Bash Bunny for all of our fun, nefarious multi-vector keystroke injection attacks and things of that nature, and that is attack mode. There are these two concepts within the Hack 5 world of hot plug devices, that you have the attack mode, which is like, hey, there's the different modes that I'm going to show up on your target as, whether it's, hey, I'm a flash drive, hey, I'm a keyboard, I'm both. You know, the Bash Bunny does a great job of also showing up as serial devices and Ethernet devices. Well, that attack mode is configurable, right? And that's our attack mode, as opposed to when we are working on the device and we're copying our payload to that device, and that what we typically call arming mode is when we just get the USB Rubber Ducky to show up as an innocuous flash drive so that we can easily copy our payload to it. Now, if you remember back in the day with the old original 2010 era USB Rubber Ducky, you'd have to pull the micro SD card out, you have to take the case off. You don't have to do that anymore. And so I want to talk about those two concepts and how to optimize your payload. And to do that, let's just go ahead and dive right in to this payload that we've been finessing, the fast Windows caps lock blinker, inspired by a payload by Atomic ZSec that toggles the caps lock key with an inline payload for Windows target systems. And hey, look at this. Right after our giant block of title, author, description, target, we've got attack mode. And this is just telling our USB Rubber Ducky what to emulate. We can do attack mode storage, and it would just show up as a flash drive, or storage hid, and it would be both a keyboard and storage. Or we could do attack mode off, and it would just turn the device off completely. Well, we, in this example, started with attack mode hid, but I'm going to tell you right now, and this payload is chock full of these, that's not the best way to do it. In fact, we don't need it at all. I can just get rid of that attack mode, and it's going to default to a hid attack mode, or an attack mode where the USB Rubber Ducky is going to start emulating a keyboard and injecting the keystrokes that we tell it to. And the reason we can omit that is because, and this is the beauty of the new USB Rubber Ducky, it is byte compatible with all of the old payloads. If you have an inject.bin compiled from an old USB Rubber Ducky payload from over 10 years ago, you can just copy it over here, it's gonna work, right? So you may be thinking about older USB Rubber Ducky payloads. They never had that attack mode command in the set. You know, original DuckyScript was delay, remark, or rem for comments, and then your injections, your string foobar and enter, right? So with the new USB Rubber Ducky, we take on, build on the Bash Bunny with that concept of attack mode, and you can actually optimize not just the speed at which your payload is being deployed, but actually decrease the amount of bytes that are in your inject.bin, because essentially what's happening is if you don't have an attack mode, it's going to default to keystroke injection, which is what all of the OG 1.0 USB Rubber Ducky or DuckyScript payloads will do. And by doing attack mode hid at the beginning of the payload, you are essentially doing this. I mean, you can put that in your payload. It's just going to take extra bytes to do that. And when the USB Rubber Ducky goes to process this, it's going to have to think for a second, and it's absolutely unnecessary. So I'm just letting you know, if all you're doing is keystroke injection, you don't have to start with an attack mode. I also wanted to point out some other default behavior, and that is the button. We can define how the button is used by doing a button_def. So I'm going to go ahead and put in button def and button, and anything in between this is going to execute whenever we press the button while our payload is executing. And hey, what if I did like LED green, and then attack mode, storage. Well, that would be a really convenient way that while we are running our payload, at any point that we press the button, set the LED to green, and go ahead and become an innocuous little flash drive. And I'm here to tell you, it already does that. Exactly what I just showed you, automatically in every single payload, whether you put that button definition in there or not. That is the default behavior. So if you've written yourself an awesome payload and you're testing it and then you're like, ah, gosh, I want to iterate on it, but now I don't want to have to break the case open and, pull the micro SD card from it. You don't have to. Just plug your USB Rubber Ducky in, and if you've done the button modification where you add a couple of layers of stickers so that you have a stealthy button that you can kind of squeeze to access, then all you have to do, plug this into your computer, squeeze it to press the button, and it's just going to become a flash drive. I love that feature, and so I love kind of explaining some of these things because, I know it's in the documentation in the big book and all of that jazz, but it's so much easier to digest in this format, and I have a lot of fun sharing these with you. And so I'm going to go ahead and get rid of this in my payload because it is superfluous, right? That's the default behavior if we don't do something else. Now, obviously, if I, instead of doing attack mode storage, I did like string foobar, then yeah, okay, now it's going to replace that default behavior, and whenever I press the button, it's going to type foobar instead of going into what we lovingly call arming mode, and that is quite simply attack mode storage, right? So for the convenient copying of our payloads. So I'm going to get rid of this because I like the default behavior, and I got rid of the attack mode, although I do want to point out while I'm here talking to you about attack mode hid, while this is superfluous and unnecessary, if you do attack mode, and you can cycle through this and see there's plenty of different templates. Let's go ahead and just choose this one right here. We can go ahead and start populating vendor ID, product ID, and then the manufacturer, the product name, and the serial number. And you might be wondering, okay, we've talked a little bit in the past about VIDs and PIDs, or vendor IDs and product IDs, and that is simply to say every USB device under the sun was made by some vendor, some manufacturer, so that's the VID or vendor ID, and it is a product and it has a unique number associated with it for that product, and that's the product ID or PID. And we can go ahead and spoof or mimic any vendor and product we want with the USB Rubber Ducky by using that attack mode command. So if you don't want to use the default VIDs and PIDs that come with the USB Rubber Ducky that so many other devices with these chips use, you can actually go ahead, and I like to head over to linux-usb.org. They've got a fantastic list of these that's well maintained, and I can actually come in here and say look for Logitech Incorporated, right? And so we can see that Logitech's vendor ID is 046D. So I can just go ahead and come into our vendor ID and pop in 046D. And I can do the same thing here with product ID. I can come down here and say like, well, what do I want to be? I want to be a Logitech gaming headset. Do I want to be a, I'm trying to find my very favorite optical mouse. Let's see, where are you in this list? K120, there we are. Keyboard K120. It's a classic keyboard. I love this thing. You find them all over offices. They're very inexpensive. And I'll go ahead and replace that. And our manufacturer, we can say Logitech if we wanted to. We could say prod K120. We could come up with a serial number like, I don't know, 00, a lot of zeros, 1337. Sure, why not? And now when we do our keystroke injection, that's how it's going to show up. It's going to look to that box as if it's a regular old Logitech K120 keyboard or whatever else you want to mimic. So I hope that clears up a lot of cool things that you can do with attack mode. If you're just doing keystroke injection, no need to have attack mode hid at the top. And if you want to get to arming mode on your USB Rubber Ducky, if you haven't already overwritten the default button definition with something else like typing foobar, just squeeze. Just do the button mod. You're going to love it. It's so much fun. You get that nice clicky, right? And nobody can see that there's actually a button there. It's a really fun hack for the USB Rubber Ducky. So this is just going to be another in the fantastic list of tweaks to this little example payload that we've been building on and learning with. And you can find this as well as so many other awesome payloads at payloads.hack5.org. It's also where you can submit your own if you want to get in the running for all of the awesome payload awards. We gave out almost $10,000 last year in awards. So we're going to be doing that again this year, and I hope to see your name on the leaderboard. With that, I'm Darren Kitchen reminding you once again, trust your Technolust. Thanks for supporting Hack5. Find all our shows, community, and pentest products at hack5.org.